All right, everybody. Lesson number 5, page 317. So we're going to take a step back here and we're going to start to look at how to apply all of this into actually factoring cubics and quartics and fifth-degree polynomials. I know we started that at the end of the last lesson. We're going to continue that with this lesson. Like, how do you get your starting point? So if we go back to grade 11, we have the graph of the function x squared minus x minus 6. We know it factors to x plus 2 and x minus 3. Multiplies to this number and adds to the negative 1 there. And this is the graph. So if I asked for the x-intercepts, you would tell me 3 and negative 2. If I said, what are the zeros, i.e. what makes each bracket 0, you would say negative 2 for that one and 3 for that one. And the equation of this has roots, i.e. you solve this, you would factor it. X plus 2, x minus 3 equals 0, which gives you negative 2 and 3, i.e. all these are the same. So that means the zeros of the function, the x-intercepts of the graph, and the roots are the same numbers. Okay, so if you hear any of those words, they all mean x-intercepts or zeros. All right, so we're going to stretch that out. We're going to look at this last one here. So here's our polynomial. Here are the zeros, or the factors. Okay, the zeros of this are what makes each bracket 0. So what makes this first bracket 0 is 2. Makes the second one is 1. Makes this one 0 is negative 1. Hopefully what you notice is all of these numbers are factors of this term. Don't need two s's in factors. Okay, doesn't want to erase. You don't need to zero. The zeros in the factored form are factors of this number. Okay, that's what you need to remember, and that's what we're going to look at this lesson. So the zeros of the function are factors of the constant term, i.e. which number has no variable. Remember that, but we're going to do it this whole lesson. Okay, so how do you find these? How do you get a starting point here? Well, you go to the constant term. Okay, this is called the integral zero theorem. I will not ask you that. So here's our polynomial. This is the constant term. What are the factors? Find the factors of that, i.e. what numbers multiply to negative 6? Well, you can do plus minus 1 times plus minus 6. You can do 1 times negative 6, or you can do negative 1 times positive 6. That's why the plus minus. Or you can go 2 times 3. Negative 2 times positive 3, or positive 2 times negative 3. Those are all the factors. So when I say list the potential zeros, all you do is you write them in the form x minus a. That's what I want you to do. Okay? Actually, that would be a factor. Write them in the form x minus a. These are all a values up here. You could go x plus 1, x minus 1, plus 2, x minus 2, x plus 3, x minus 3, plus 6, x minus 6. Those are the potential factors of that polynomial. Or, if you want to shorten it, you can just go x plus minus 1, x plus minus 2, x minus 3, x plus minus 6. I will do it that way, but it's your choice if you want to write them all out. That's all you have to do is look at the last term, figure out all the numbers that multiply to it, which is here, and then write them in the form x minus a, and those are the potential factors of your polynomial. We're going to this example right here. Okay. So I ask you to factor this polynomial. And you're like, well, it's a fourth degree. Okay. The first thing you do, go to the constant. What are the possible factors? What are the factors of 12? I.e. what multiplies to 12? Well, always do plus minus. We could go 1 times 12. We could also go, plus minus 2 times 6. And 4 times 3 again. And you always do plus minus. Okay? Because negative 4 and negative 3 will give you positive 12. That's why it's always plus minus. Now, how do you write these? So the factors, those are the potential zeros. If you're going to write the factors, the possible factors, which they don't ask, but we're going to do it just so you know what I'm talking about. Possible factors are x plus minus 1, x plus minus 2, x plus minus 3, x plus minus 4, x plus minus 6, and x plus minus 12. Those are the potential factors. Now we have to factor it. So which one is a factor? Well, how do we know if something is a factor? It's a factor if the remainder equals 0. That was the last lesson, right? Lesson number 4. So if the remainder equals 0, it's a factor. So we can figure out the remainder. Now, on a test or an assignment, I'm not going to make you test each one. I will narrow it down to 3. In this case, I'm just going to tell you which one to use. Using a is equal to 1, which means our factor that we're guessing is x minus a, so x minus 1. So we're going to do synthetic division. So 1 goes on the outside. We're dividing this polynomial. So we put in all our coefficients. 1, 2, negative 7, negative 8, and 12. Bring down the 1 times 1 is 1, 3, 3, negative 4, negative 4, negative 12, negative 12. We got a remainder of 0, which is good. Therefore, x minus 1 is a factor. Okay, so how do we write everything? We always write it as dq plus r. What's our divisor? It was x minus 1. What's our quotient? Well, we started with a 4th degree. We're always dividing in this class by a numerator, so that goes down by 1. So our quotient is this bit right here. So it's x cubed plus 3x squared minus 4x minus 12. That is our quotient. So that's what goes here. My q. So I get x cubed 3x squared minus 4x minus 12. And you normally go plus the remainder, which is 0, so you don't even have to write that. But we're not done because this can be factored again. Now, obviously, you would have to try all the possible factors of that, which are going to be the same as the ones up here, because it's still 12. So what we do is I would narrow it down for you. So I'm going to say use a equals 2, which means we're actually testing the factor x minus 2. So again, you do synthetic division, but just on this bit now. So 2 goes on the outside. We're only doing synthetic on this. So we're going to go 1, 3, negative 4, negative 12. Down the 1, multiply by 2, add, you get 5, give me 10, that gives me 6, that gives me 12, which gives me 0, which is good, which means x minus 2 is a factor. Therefore, x minus 2 is a factor. All right, again, we write it as dq plus r. So, I'm going to keep using different colors here. Let's go black. So, I can now write it here. P is equal to dq plus r. So, you have to remember this is still there. So, the x minus 1 is there. We used x minus 2. Our new quotient is going to be x squared plus 5x plus 6, because we went from a third degree down to a second degree. X squared plus 5x plus 6 plus a remainder, which is 0. Then the final bit, this is a regular quadratic. So it's what multiplies to 6 and adds to 5. So the final factored form is x plus 2, 3. That is your answer. If you multiplied all of these out, you would get back to this polynomial up here. Okay, so that is a fourth degree polynomial that you just factored. I will always narrow this down. Okay, I won't just tell you, I will narrow it down to a couple that you have to choose from. And then you would do the division or use the remainder theorem when the remainder is 0. If it is, then it's a factor. If they ask for the roots of the equation, basically what makes each bracket 0. So the roots are going to be what makes this bracket 0, 1 makes this bracket 0, 2 makes this bracket 0, negative 2, and then negative 3. These are also the x-intercepts, which are going to become important in a couple of lessons. Graph. All right. So always go to the constant term, write out all the possible factors. All right. To see which one is a factor of the function, divide it, see which one is a remainder of 0, rewrite it as dq plus r. If it's a cubic or a second degree, factor again, etc., etc. Keep going until you can't factor anymore. Questions I want you to do are number 1. I'm going to tell you use x plus 1 as your factor. Number 2, use x minus 1. And then number 6, you're going to have to do it twice. X plus 2 and x plus 1. Try those. These are the factors that I want you to use, i.e. what you're dividing by on the outside. All right? That's it for this lesson, very short. I will also post another lesson soon. Again, if you have any questions, please email. Thanks.